Okay, so this is 8-2, and now we're talking about inconsistent and dependent systems. I'm actually going to go down to the bottom of the page really quick. Um, Back in chapter 7, we talked about intersecting lines, so, lines that intersect at a single point here. We talked about lines that were the same line, so they graphed right on top of each other, and then we also talked about parallel lines that never intersect. Well, we can have the same thing with a system of equations in 3 variables or 4 variables, and we want to look at how it happens in a matrix. So intersecting lines are like what we were seeing in 8-1, where we got exactly one solution with however many variables. It's consistent and independent, and we were able to get it into this reduced row echelon form. Now, when we see either a same line or parallel lines happen, the same line is going to end up looking like this, where we are able to get a 1, zeros below, zeros above, but no 1 right here, and we'll also get a 0 here. So the thing you want to note about same line is that you get zeros all along right here, okay? Now, when you get a solution to this, it's going to look something like this, where you get your x value in terms of z, so some function f of x in terms of z, and then some function, different function g of x in terms of z, and then z. Okay, so these will have, actually, I should have put z's in here, not x. So some function of z and some function of z. And then in the last one, in parallel lines, they never intersect, they never touch. So you're going to get zeros all the way here, but you're going to have a number left there. And so there's no solution. Okay, there's no solution there. You won't be able to write it like this. You would just write no solution. So let's go ahead and look at an example here. So we're going to go through the same process we went through in 8-1. So first, I'll go ahead and write it as a system. 1, 2, 3. -1, -3, -4, and -2, 6, 4, draw that line, 2, 5, and 12. And then we'll go ahead and start our process of getting it into row echelon form. Now, as we gain experience with these, we can go ahead and start combining steps. So I'm going to multiply, since this is a 1 right here already, multiply it by -2, and add it to row 2. And I'm also going to multiply -3 times row 1 and add it to row 3. So row 1 is not changing. I'll go ahead and just copy that down. And then row 2, we've got -2 times 1 is -2 times 2 is, or plus 2 is 0. -2 is going to give me a -1 right here. -2 times -2 is going to give me a 10 right here. And -2 is going to give me a 1 right here. And then doing the same thing with row 3, -3 times 1 is going to give me a 0 right here. -3 is going to give me a -1. -3 is going to give me a 10. And then -3 times 2 and adding to 12 is going to give me a 6. Now already I can kind of start to see something interesting happening here, but I'm going to take this one step further just to get it into the form we're looking for. I'm going to multiply -1 times row 2 and add it to row 3. Okay, so rows 1 and 2 did not change, so let me go ahead and copy those. And adding -1 times -1 is 1, plus that is going to still just be 0, and 0, and 5. And so we're left now with this form we looked at the bottom, where we've got 0, 0, 0 number, 0, 0, 0 number. So what that means is there are no solutions. And if it asked us to identify what kind of system, it's an inconsistent. And we can stop there. Okay. So let's go ahead and move on to the next example, and you can probably guess what type of example we're going to see happen here. But let's just continue working through it like we aren't sure what's going to happen here. So we have 3, 1, 2, -4, -1, -3, 4, -2, 6, and 7, 2, 5. And there's our matrix. So let's go ahead and start solving it. First thing I'm going to do is switch rows 1 and 2 so I get the 1 in that top left corner. So they're switching places. Okay. And now we're going to go ahead and try to get this into the form we're looking for. I want to try and get zeros here, so I'm going to do the same thing I did in that first example. I'm going to go ahead and multiply row 1 times negative 3 and add it to row 2, and negative 2 times row 1 plus row 3. And we don't change row 1, so 1, negative 2, 2. And then this is going to make a 0. Negative 3, that'll give me a negative 1. Negative 3 will give me a 10 here. Negative 3 adding will give me a 1. And then I end up doing the same thing for row 3. Give me a 0 here. It's going to give me a negative 1 here, a 10 here, and it's going to give me a 1 right here. And then what we'll be able to do is notice that these two rows are the same. So taking it one step further, negative 1 times row 2 plus row 3. We can go ahead and cancel that, get zeros all in the denominator, or in the bottom row. Okay, and now we're in that infinitely many solution scenario. But we still need to go a step further with these. They're not quite as easy as the no solutions. So let's go ahead and write it back as a system. X minus y minus 2z equals 2. Negative y plus 10z equals 1. And then we have 0 equals 0. Okay. Now, since we don't know what z is, this is a 0 right here. I'm actually going to write this out for you guys. So since we don't know what z is, we will write x and y in terms of z. So z is continuing to stay a variable. So when I ultimately write out my answer as a coordinate, I'm just going to have z here, and then these two are going to be equations in terms of z. Okay. Now, I can already solve for y in terms of z, so negative y plus 10z equals 1. I can subtract and divide by negative 1, and y is going to equal 10z minus 1. So in this spot here, 10z minus 1 is what y is. And I can do the same thing for x. I've just got to substitute some things in there. So we have x minus 10z minus 1 minus 2z equals 2. And solving for x, x is going to be equal to 12z plus 1. And that's what we get here. And this is infinitely many solutions. If it asked what kind of system, it's consistent and dependent. Okay. And that's the end of section 8-2.